Welcome you to one of two New York State's Geoparks. These were donated to the New York State Museum in World War I. Both of these are world famous. This locality is Leicester Park, and it is one of the 100 most important geologic sites in North America, according to the Geological Society of America. And it's known, it has this status because we have this ancient marine rock surface that's covered with structures that are called stromatolites. Fancy term, all that it means is layered rocks. This is an ancient sea bottom. We are walking in water that may have been only knee deep. You see the cross sections through the stromatolites, and you see they were growing outward, and they should actually form high domes, but they've been planed off. They've been truncated. This has been thought in the past to be the result of glacial action that planed them down. No, this is not the case. In fact, they were planed down shortly after they grew. A vertical cross-section then shows all of these growth laminae, and at the very top, things flatten out, and invariably there's sand covering these stromatolites. So what happened was they were growing, they were then truncated by a change in environment that washed sand across the surface and abraded these stromatolites down. This is what stromatolites look in cross-section. See the quarter for scale, and you have these domes that indeed are coming up. Sometimes the domes are really very crinkly. Many stromatolites are formed by something commonly called blue-green algae, which is cyanobacteria. However, in the case of Leicester Park, very recent work shows that there are laminae of cyanobacteria, and then there are laminae of a keratose sponge. Can't really see that except under the microscope. So these classic stromatolites have a complex structure, including a bacterium and a very primitive metazoan called a keratose sponge. How do we know the age of this rock surface and the stromatolites? Well, it's based on associated fossils, in particular marine animals called trilobites. These are trilobites, these are their heads, these are their tails, and by looking at the assemblage of trilobites, and because extinction has taken place in geologic time and evolution has taken place, you'll end up with an assemblage of trilobites that gives you a relative age. And the relative age of the Leicester Park stromatolites is very high in the Cambrian. We don't have a numerical age at Leicester Park, but we can take these trilobites and say, what is their age when they're found with something that can be dated, like a volcanic ash? And I've done this work with volcanic ashes, and the Leicester Park stromatolites come out as 490 million years ago. Now, don't do any collecting here. This is a preserved locality. You would find trilobites, but the key thing is that you've got stromatolites with trilobites. Usually you don't have other animals with stromatolites because it's very restricted marine conditions. In this case, the Leicester Park stromatolites are growing in normal marine waters. There are several acres of land at Leicester Park. The park extends across the road, and you can end up seeing approximately 50 feet of rock. The lowest rock above the stromatolites is at the road cut just down the road. These are higher rocks at Leicester Park. The road here is several feet above the stromatolite surface, but basically what you end up having is the stromatolite surface is abruptly covered by shales. That's the recessive interval in here. The shales are not fossiliferous, are poorly fossiliferous. Actually, no trilobites. They do have brachiopods. Higher, there is limestone, and the limestone has a reappearance of stromatolites. So stromatolites mark a particular type of rock, and they seem to mark what we call a shoaling event. The muddy, shaly interval right down here is it breaks into thin layers. It gets a little thicker bedded. It's becoming more and more limey, and then it becomes a good limestone as you go higher. And higher in that limestone, again, are stromatolites. So this marks a shoaling up sequence as the geologist would see it. A bit across the road and is a lime kiln that you see marked with a sign. The kiln was used to burn limestone for agricultural lime because the soil is so poor here. And there is also a path that leads to the Hoyt limestone quarry that we will also take a look at. This is the Hoyt quarry, which is the upper part of the Hoyt member. This rock had been quarried and it was burned really for a sort of quicklime used as a fertilizer on very sandy local soils. What is exposed up here is a different type of cyanobacterial buildup called a thrombolite. Here's one here, and here's another one right here. And what you end up seeing is kind of a chaotic bedding, and it's made of sort of a cloddy material. It has empty spaces surrounded by buildup. The thrombosis refers to lungs. It refers to the clotted fabric of thrombolites. Just like the stromatolites below, thrombolites here are associated with a rich marine fauna. You name it, trilobites, echinoderms, brachiopods, all indicating that these were normal marine facies. Now you find stromatolites, thrombolites in West Australia now. There are no associated animals. And the lack of those associated animals means that cyanobacterial mats will build up, they won't be fed on. In this case, the mats are building up to make stromatolites, they're building up to make thrombolites, and there's nothing grazing them. This is an interval in the evolution of marine animals that did not feature grazers quite yet.